Welcome back to the Explainer. So let's just dive right into it today because we are taking on a full-blown masterclass in Node.js modules. We are going to take those messy, sprawling, frankly terrifying code bases and transform them into beautifully clean architecture. If you have ever felt completely overwhelmed looking at your own code, well, you're absolutely in the right place. I want you to really picture this for a second. What actually happens when your entire application is jammed into a single massive 1,000-line file? You're endlessly scrolling through database logic, business rules, and HTTP handlers, and it's all just tangled together in one giant knot. And then, say a colleague needs to tweak the payment logic at the exact same time you're working on something else, every single save creates a merge conflict. It's an absolutely visceral pain. But the good news? This exact problem is precisely what module systems were built to solve.
Okay, let's establish the mental model here using a really simple recipe book analogy.
Think of a module exactly like a self-contained recipe in a high-end restaurant's recipe book. A pasta recipe has its own unique list of private ingredients, right? Those ingredients are kept separate. They don't leak out and mess up the other dishes in the kitchen, or, in our case, pollute the global scope. But what if the head chef whips up a fantastic base tomato sauce that 3 other dishes also need? Well, they write that sauce recipe down once, explicitly export it, and then those other recipes can just share it. So you write the logic once, you export it, and literally any other file can import it.
Next up, let's talk about CommonJS export patterns, specifically focusing on how we use module.exports.
We're going to progressively build through 4 essential export patterns here. We'll start off really simple with just a single value, then move into objects and destructuring, and finally wrap up with advanced stateful class architectures. First up is the single value export. Here, we are directly assigning just one function, in this case, a simple add function, straight to module.exports. When another file explicitly requires this math file, the entire export is just that function itself. You run it, and boom, you get an output of 10. It is explicit, it's direct, and it does exactly what it says on the tin. Now let's level up a bit by exporting an object. Instead of just one function, module.exports is now an object holding multiple functions, like add and multiply. But what's really cool here is what happens on the import side. By using object destructuring, the file doing the importing pulls out exactly what it needs and nothing more. If your module exports 10 functions, but you literally only need 2, just import the 2. It keeps your logic so incredibly clean, and honestly, your static analysis tools will absolutely love you for it. Finally, we have exporting a class. Notice we are exporting the calculator class itself, not an instance of the class. This means the file importing it gets to use the new keyword to spin up its own completely isolated, stateful instances. And since each method returns this, you get to chain the methods together in this really elegant way. You'll actually see this massively common pattern all the time for things like database connection handlers, where you absolutely need to safely manage state. All right, moving into the internal mechanics, let's look inside the require engine and see how Node actually loads these files under the hood. So here's the crucial thing. Node does a very precise 3-step dance when you call require. Step 1, it resolves the path based on its prefix. So it checks if it's a relative, // a package living in node_modules, or maybe a built-in node module. Step 2, it loads and compiles the code by wrapping it in a protective function. And step 3, and this is a big one, it caches the execution. Let's actually zoom in on that second step for a second. This right here is the hidden wrapper function that Node invisibly injects around your code every single time. This is literally the exact reason why your variables stay private to their specific file. It's also how magical objects like module, require, fill name, and dir name are just suddenly available in your files without you ever having to manually import them. Node is just secretly passing them in as arguments to this invisible wrapper behind the scenes. Okay, now for a bit of a magic trick to test step 3, the require cache. Take a look at this setup. We've got a shared counter module tracking state. Module A requires it and then increments that counter twice. Then module B requires the exact same counter and increments it just once. So pop quiz, what do you predict module B is going to print out? It outputs 3.
Not one. Crazy, right? It outputs 3 because both module A and module B are pulling from the exact same cached object in memory. Node doesn't bother rereading the file, it doesn't re-execute the code at all. It just hands over the exact same object from its cache, which by default creates a shared singleton state. Trust me, keeping this cache behavior in mind will save you hours, literally hours, of frustrating debugging down the road.
Okay, let's put all of this into practice. It's time for the clean architecture refactor, applying the principle of separation of concerns.
Remember that massive monolith we talked about at the start? We are going to split that up into distinct, completely isolated modules, where each file has exactly one job. We create a config module exclusively for environment variables. We make a project reader module strictly for file parsing logic. And we build a display module that only knows how to format console output. Notice how incredibly clean this makes our dependencies. We know exactly what each file requires to do its one specific job.
Ends the payoff? Our sprawling, terrifying index file beautifully transforms into a simple, lightweight orchestrator. It neatly groups all the imports right at the top. And by the way, professional convention dictates you put built-ins first, then npm packages, then local files. After that, it simply coordinates the work inside a nice, clean try/catch block without containing a single drop of the messy business logic itself. This right here, this is highly maintainable software architecture in action.
Now we definitely need to touch on ES modules and the modern import and export syntax you're bound to run into.
While the core concepts we've talked about are completely identical, the syntax gets a modern facelift here. ES modules swap out require for the import keyword, and they trade module.exports for the export keyword. But here is a massive gotcha. ES modules require you to use explicit .js extensions in your local import paths. People forget this constantly. To actually enable this modern syntax, you either need to use .mjs file extensions or just set type module directly inside your package.json file.
All right, before we wrap up, let's look at 4 common module mistakes. These are the classic traps you definitely want to watch out for. Mistake number 1, circular dependencies. This is where file A requires file B, but file B requires file A. It creates these awful, silent, hard-to-trace bugs. Second trap, simply forgetting to actually export your function. If you do that, require is just going to silently return an empty object with 0 errors to warn you. Third, breaking the exports reference. This happens if you reassign exports directly using an equal sign instead of correctly using module.exports. And finally, missing the / in your local require statement. If you just type require math without the /, you're tricking Node into endlessly digging through your Node_modules folder instead of just looking at your local file right next door.
But if you avoid those traps, the result is a beautifully structured codebase. Look at this. We now have 6 source files, cleanly organized in a source folder, each with one crystal clear responsibility, sitting nicely alongside our coordinating index and package files. When you understand modules on this deep level, your logic becomes infinitely testable and totally maintainable. And the best part is, these exact principles hold true whether you're working with 6 files or 600.
And that basically wraps up our masterclass on modules. But understanding this opens up an even bigger, much more fascinating mystery about Node.js itself. Namely, why can Node handle tens of thousands of concurrent connections using only a single thread? It's kind of mind-blowing when you think about it. So next time on The Explainer, we are diving deep into the event loop, the call stack, and libuv to unpack the real secret behind Node's single-threaded power. You absolutely will not want to miss it.